We did a filtration of the current known fluids, so basically started with the 241 R numbers we have in ASHRAE 34 and ISO 817. And if we just take the first 241 and remove the ones that are banned due to ODP in the Montreal Protocol, we're left with 200. If we want GWP to be below 150, and we can see with the current phase down, we will need to get down there. We have 95 left. Removing the ones where the boiling points are outside what we usually would call useful, then 76 left. Now, if TFA becomes a significant issue from a legislative point of view, we have 53 left. If the legislators, instead of regulating on TFA, goes and regulates on whether it's a PFAS according to the OECD, then we are down to 45. The current proposal in the EU that's being debated quite a lot in the industry, that uses the OECD PFAS definition. Of these 45, the majority of them are what you would call natural refrigerants. Actually, a large portion of them are blends of hydrocarbons. And only 14 of them are synthetic refrigerants. Or in this case, actually, refrigerants with either fluorine or chlorine or iodine in it. And if you then look at how many of these have a low glide or small glide, it's only 8. And if we go a bit more into the details, then it's just successful. Then we have all the hydrocarbons, or you can say the natural refrigerants, make it through the filtration. But we also find stuff like sulfur dioxide and multiple hydrocarbon blends that are not really interesting from a commercial point of view. If we look at the pure synthetic fluids, none of them are really useful as refrigerants, but they can be relevant in new mixtures. Daniel already alluded to this, and I'll go a little bit more into details in a minute. There are molecules that have PFAS structures but don't generate TFA. So there is a group of molecules where you can say it depends actually on what the legislative framework ends up being, whether they will be useful or not useful. One of these could be 1234CE, where there is a strong reason to suspect that the TFA generation is actually 0%. On the other hand, it does have a structure that would be banned if we use the OECD definition of a PFAS. And then we also spot some CO2 blends where it's mainly CO2, but they modified the thermodynamic or thermophysical properties by adding other molecules. And we'll get a little bit more into details with this, but in addition to the 241 current fluids, we could have something new coming in the future. But there is a limit to how much we could expect. Thomas Midgley, back in 1937, stated that there are only, he actually said 8 potential atoms to build refrigerants from. Now, I would add today we might consider whether iodine should have been among these. But iodine does give problems with ozone depletion and sometimes also toxicity and stability. There has been a very large series of studies where a research group has screened more than 60 million molecules. And they didn't find anything new. They didn't find anything we didn't know already. They did a recent follow-up study where they did point out 2 new candidates, 1132C, which probably would be a B2 fluid, though it's not quite clear. Most likely would have stability issues. Could also be trifluoropropene, probably an A2 fluid, though the toxicity is not actually quite clear. Could be stability issues, and this one would actually be hit by a PFAS ban. Then in addition to this, we have proposals or have seen proposals to use 1123 and 161, but neither of these have actually been getting an R number in ASHRAE or ISO. But if we look at this, then you can see that all the molecules that are being proposed at the moment have actually previously been looked at, and they have previously been deselected. But now people are thinking, okay, since we don't have anything else, maybe there's something that could be useful in a mixture or something similar. A mixture with something else.